To determine the bond type, you take one of each element, find their electronegativities. For example, calcium is 1.0. We're going to take the absolute value of the difference between the two elements. Oxygen is 3.5. And if I subtract 3.5 and 1.0, I get 2.5. When you look at the scale that's provided for you, 2.5 is greater than 2.0, which makes this categorized as ionic. So this first one is ionic. Next we have N2, which is 2 nitrogens. Nitrogen is 3.0, so it's going to be 3.0 minus 3.0, and that equals 0.0. So when you look at the scale, 0.0 to less than 0.4 is nonpolar covalent. So this is nonpolar covalent. Next is AlF3, and that's going to be one of each that I want to subtract. So Al is 1.5 minus F is 4.0. I am not worried about this 3. I just want one of each element. When I subtract these two numbers, I get 2.5. I'll just do 4 minus the 1.5 because I want the absolute value. And then when you look at 2.5 on the scale, it is greater than 2.0, which makes this ionic. Lastly, Be and Cl. I'm going to take Be, which is 1.5, minus Cl, which is 3.0. And when I do 3 minus 1.5, I get 1.5. And when I look here, 1.5 falls between 0.4 and 2.0, which makes this polar covalent. Once you've identified what type of bond it is, then you can describe what that bond is. For example, the first one and the third one are ionic, which means the electrons are transferred between the elements, resulting in positive and negative charges that are held together by electrostatic attractions. This one that's nonpolar covalent means that the electrons are being shared equally. There are no charges, and this tends to happen when you have diatomics or two identical atoms. And then polar covalent is an unequal sharing of electrons. You get partial charges on each of the elements, and it tends to form between not identical atoms.